In the science storyline approach used in OpenSciEd, the sequence of activities is designed to make sense to students. These storylines were developed based on the input from hundreds of classrooms and the questions that students actually asked. So let's dig in and see how the story of Unit 8.1 unfolds. OpenSciEd units are organized into collections of lessons called lesson sets. And a lesson set is just a group of lessons that's focused on figuring out a part of the phenomenon. At the end of a lesson set, students put together their ideas to explain what they can at that point. In the first half of the unit, students investigate how objects interact when they make contact in a collision. Now that we know more about contact forces and collisions, lesson set 2 is focused on figuring out how changes in energy are related to force interactions. Lesson set 3 is the design challenge, where we apply what we've learned about contact forces to design a new and better phone case, returning to our anchoring phenomenon. All right, so let's see how this looks. In lesson 1, our anchor, we figure out that millions of phones are damaged a year in our country and that many of us have experienced such damage firsthand. We have a lot of experiences where a collision between two objects caused damage and experiences where it surprisingly does not. We develop initial explanations, DQB questions, and ideas for investigations. And we're wondering, can we look more closely at what happens when different kinds of things collide? So, in lesson 2, we investigate collisions between different objects and we figure out that we can see changes in motion, but we aren't sure if all objects, especially really rigid ones, change shape during collisions. We need more evidence. So, in lesson 3, we watch slow mo videos of cars and other rigid things visibly bending and changing shape during collisions. We observe a piece of glass and concrete also bend when something pushes on them. So we figured out that all solid objects deform, but we are wondering how much force does it take to deform any solid object? So in lesson 4, we do a material deformation lab, and we figure out that all solid objects have an elastic limit and will deform up to a point when forces are applied to them. But we really aren't sure which objects are getting pushed on and which are doing the pushing in a collision. In lesson 5, we see that when one of two objects is pushed against the other, both deform. And the peak force on a spring scale is the same as the peak force on another spring scale when they make contact with each other. So now we have a model that we think can be used to explain why some objects break and some don't in a collision. And we want to test this idea on some of our initial questions. In lesson 6, we apply what we figured out about properties to explain a related phenomena, soccer related injuries. During our discussion of the assessment, we discovered that we have conflicting ideas about what would cause more damage, increases in the mass or increases in the speed of a moving object.